Attention, ladies and gentlemen, welcome to our masterclass, if you like, our Q&A session, if you prefer. I like to have these meetings here with you all, these sessions with you all, open sessions with you all, to talk about relevant topics in terms of Lean Six Sigma, to maximize the chances of you being an amazing belt, an amazing Lean Six Sigma professional. Okay, so I'm gonna start today playing here a little bit of guitar, maybe just one song before we get started with this important topic that is histogram. Okay. Okay. So please, how is my audio? On a scale from 0 to 10, please, how is my audio? I hope you can hear me okay. And let's talk a little bit about this important, this famous graphical tool named Histogram. Okay, let me just change here, and then please let me know if you can see my screen okay, and if possible type here for me where are you in the Lean Six Sigma journey. Okay, olá Ricardo, tudo bom? Where are you in the Lean Six Sigma journey? And once again, let's deep dive on this important tool named Histogram. Okay, as you know, every time that we have, let's consider any data set. Okay, any data set. Let me generate here some random data. 100 data points. Let's put here in data. Mean 10 and standard deviation 1. Yeah, let me just generate some random data here. So probably you know that we want to look to this data set and extract from this data set important insights. Yes? At the end of the day, we want, with this data set, to translate this data into solutions and preferably the right solutions. We want to be assertive, right? I talk about this since white belt, since certification, the very first level, that is white belt. It is about being assertive, yes? And as part of that, we can argue that we must know at least 3 dimensions. We must consider at least 3 dimensions on any data set that we get. On any data set. These dimensions are location, location, or if you prefer, central tendency, yeah, spread, and shape. Okay? Location, for example, mean, median, mode, yeah? I can argue that my data is located, yeah, it is located at the average of 10, of 15. But there is a spread. We do have some variation, yeah? Standard deviation, variance, or range, yeah? Wonderful. But we also wanna know the shape of the data. Interesting, the shape of the data. Why? Why am I interested in knowing if the shape of the data looks like a bell? Why do I want to check if I do have a bell-shaped curve? Why is it important? You know, why is it important? Why would I check if my data is skewed? Why? Because understanding the shape of my data is the first step in the process of projecting the results of a sample to the population. It is the very first step. Understanding the shape of the data is the very first step in the process of projecting, of inferring, taking a sample and then projecting the results to the entire population. And by far, one of the most powerful tools, graphical tools, to give us an initial idea of the shape is histogram. Yeah? And histogram we can find here, graph, histogram. And by the way, let me do a zoom in. So once again, you can find it here. Graph, histogram. Graph and histogram. And see, with histogram, I can check the shape and spread of your data by using bars to show the frequency of data within each interval. It works best with moderate to large samples, meaning at least 20. With histogram, I can also see location. I can see shape, spread, and location. Yeah? But here, the most important thing for us to check is shape. Yeah, it's definitely shape. Yeah? Yeah, I'm gonna show Mirage. Yeah, what do I mean by shape? Yeah? And by the way, let me do something here. Normal data, non-normal data. Yeah, so even without exploring how does histogram operate, let me show you guys here. And then you tell me if you see any difference, in these two graphs here. You guys tell me. Do you see any difference? Yes or not? Type here in our chat window. In terms of shape, can we argue that this shape here is similar or different from this shape here? It is similar or different from this shape here? Yes, they are very much different. Very much different. And it is important to understand the shape. Why? Because then, knowing the shape, again, it's the first step for us to identify the probability distribution that better explains our data. And then we can start projecting. Yeah? From 0 to 10, how much sense does it make? Or is it making so far? Because then what I want to do with you is to explore here. It is to explore here with you. I want to explore here with you. How does this tool operate? I want to explore with you. How does this tool operate? Yeah, so for example, when I take this bar here, yeah, and I see value equals 1 being from 6.75 to 7.25, what does it mean when I take this bar here and I see 22, yeah, and I see an interval from 9.25 to 9.75, yeah? So what does it mean? What does it mean? Yeah? So, few things that we need to reinforce here. Histogram. Histogram has nothing to do with Pareto. This is not a kind of Pareto, because we have bars here and it's similar to Pareto. It has nothing, zero to do with Pareto. Zero, 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 zero. Pareto, on the x-axis, we have categories. We have discrete variable, yeah? Very differently from histogram. Pareto is for prioritization. Number, for example, number of defective items. Yeah? Histogram, I'm talking about continuous data, and I have frequency on the y-axis, and I have the absolute values on the x-axis. So it has nothing to do, it's not like a simple bar graph. It's not like a bar graph, you know, or a Pareto, you know. Histogram is about taking the first step in the journey of identifying the best probability distribution that explains my data. So I can start inferring, projecting, for example, for capability analysis. CP, CPK, PP, PPK, sigma level. For example, for a hypothesis test, for a normality test. Yeah? So from 0 to 10, how clear it is when I say that histogram has nothing to do with Pareto. Nothing. This is not like a kind of Pareto. Yes, it is not. It is not. Okay, so let's understand how does it work. Okay, so when I say that there is a bar like that, and there is, take a look, value 1, and there's a bin, there's an interval from 6.75 to 7.25. Okay, so what's the size of this interval? What's the size of this interval? The size of this interval is 0.5, from 6.75 to 7.25. Marcelo, but I see only one number here. I am seeing only one number here. Yes, it is only one number, but you can be sure that this bar does not represent the fact that we have one data point equals to 7. Did you understand that? Histogram is not telling us. Many people think that histogram is saying, okay, I have one data point here equals to 7. And it is not. It is one data point from 6 6 point. This is terrible. 6. It's hard for me because I use this mouse, you know, so it's hard to draw. But I can put a text here. Let me see if it is better. From 6.75, yeah, to 7.25. 7.25. Yeah. So we must understand that it is from 6.25 to 7.25. And we can track that. Yeah, we can track that. Let's change the color here and put as red, for example. Yeah. And let's now sort our data. Let's sort our data. Yeah, and see that we have here one data point. Yeah, one data point. Let me put here, yeah, let's put the same red. Yeah, we have one data point that is 7.16. 7.16. Yeah, and my question for you is, is 7.15, this value here, 7.16, is 7.16 lying within this interval, yes or not? Is 7.16 lying in this interval? Yeah? Yes. And by the way, in this interval here, 6.75 to 7.25, I have only one. And that's why I have here one. That's why I have here one. I have just one data point. Just one data point. Oh, interesting. Very interesting. So if I take, for example, this bar here. If I take this bar here. If I take this bar here. See that the interval is from 9.75 and 10.25. 9.75, 10.25. I have 17 values from 9.75 to 10.25. Okay, so here in this bar, I will find numbers, yeah, from 9.75 to 10.25. 10.25. Yeah. And once again, how many data points? Type here for me. How many data points do I expect to see from 9.27, from 75, I'm sorry, 9.75 to 10.25. How many data points, guys? Yes, I do expect to see 17 data points. 17 data points. Yeah, so let's see. 9.75. Oh, this is the first one. Yeah, because this is below 9.75. So this is the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. No, 18 no, because 10.2679 is out of my interval. It is out of my interval because my interval goes from 9.75 to 10.25. Yeah? So I can come here and I don't know if this is the same green that I have used. Yeah? So once again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17. When I come here, once again, I see that I have 17 data points that fall between 9.75 and 10.25. And then if I keep doing this very same exercise, if I take this last one here, and let's put purple. Purple. So I should see only one data point from 12.75 to 13.25. $12.75 yeah, from 12.75 to 13.25. Yeah, just one data point. So once again, I have a data set. I have a lot of different numbers. I can come here and calculate, for example, a mean or a median. So I have a location. I can calculate, for example, a parameter if this is population or a statistics if this is a sample. For spread, like a range, standard deviation, or variance, yeah. But shape is particularly important, again, because we are projecting. We want to project. We want to understand if this data behaves according to a normal probability distribution, because then I can, for example, go ahead and run my capability analysis considering normal probability distribution, yeah. And so what is the mechanics? What is the mechanics of histogram? With histogram, you will be grouping. You will be grouping your data set, yeah, in different bins, different intervals. The size of these intervals must be the same. So when we have a histogram, please keep in mind that this dimension here, that is 0.5, is the same of this dimension, that is the same of this dimension, that is the same of this dimension, same of this dimension, same of this dimension. Yeah? And then having the intervals, having the bins, it's just a matter of placing the data, yeah, the number of data points in each bin, and then with that you will have an amazing picture in terms of the shape, and then you can see if this is a normal distribution or if this is exponential, or this is maybe log normal, this is Weibull. Yes, wonderful. And once again, it is extremely important when we are talking about projecting our data. From 0 to 10, how helpful was that? From 0 to 10, how helpful was that? Once again, the reason I run these sessions that normally they go from 30 to 60 minutes, sometimes a little bit more. The reason I do this is really to maximize the chances of you becoming an amazing belt. Okay, that's my objective with you. Okay, so I hope you've enjoyed this session about histogram. I just have a final piece. Oh, I'm glad to know that, Miraj. I'm glad to know that. Maybe one question that you have is, Marcelo, how to define the size of the bin? Is this a good question? How to decide the size of the bin? Is it a good question, yes or not? And there are different methods. Amy. Yeah? Minitab uses one that is not super complicated, but it is not super simple. And I would like to share a very used method that is not, it is not the method that Minitab uses. But in case you are using another software, you are using Excel, for example, or even by hand, yeah, you can do this very easily. That is the number of beans, or the number of bars, can be estimated. And again, this is not the way Minitab do, so it will not match with the results that we have here. The number of beans or the number of bars can be defined by the square root of sample size. Square root of sample size. So in this case, I have 100 data points. The square root of 100 is 10. So you know that you have 10 bars in your histogram. Okay, Marcelo, how do I define the size of the bean? One of the ways is you take range and you divide by the number of bars. So let's suppose you have numbers that vary from, your lowest number is 1000 and your highest number is 1500. So the range, max minus mean, is 500. So I know that my numbers, they vary from 1000 to 1500 to 1500. So you take 500 and you divide by 10. So you have beans by the size of 50. So you'll be placing all data points, from 1000 to 1050, and then 1050 to 1100, 1100, and so on. Yeah, so this is one of the ways. Okay, ladies and gentlemen, yes, actually I'm thinking about that and how the interval value are decided. Ladies and gentlemen, it is always a pleasure to be here with you all. This session will remain available here. Yes, I like to run these open sessions, regardless if you are a white, a yellow, a green, a black, or a master black belt. And I am so happy to have this opportunity, to talk to you all. I hope this session was helpful for you, and I hope to see you again soon.